This is the Electricity Homework Booklet, question 7. The critical temperature of tin is minus 269 degrees Celsius. The resistivity of tin increases as its temperature rises from minus 269 degrees. Define resistivity. Resistivity is always defined using the equation, and this equation can be found on your data sheet. What you must do, however, is state what each symbol represents. So R is the resistance of a length L of wire, and A is the cross-sectional area of the wire. It is essential to include the phrase cross-sectional. Next, state the significance of the critical temperature. This is the temperature below which resistance or resistivity is 0. This means that below the critical temperature, a material becomes a superconductor. Finally, a calculation. A sample of tin in the form of a cylinder of diameter 1 millimetre and length 4.8 metres has a resistance of 0.7 ohms. You are asked to use this data to calculate a value for the resistivity of tin and to state an appropriate unit. So, quite simply, substitution into the equation for resistivity, but do be careful. For the area, you want to say pi r squared, but you were given diameter, so you need to divide by 2. You also need to handle your units carefully and replace millimetres with times 10 to the minus 3. 4.8 was in metres, so that makes these two values now in consistent units. That leads you to an answer of 1.1453 times 10 to the minus 7. If you were rounding that to 3 significant figures, you would say 1.15. But if you were rounding it to 2 significant figures, 1.1 times 10 to the minus 7 would be the best answer. The mark scheme awarded a separate mark for the units here, so it's very important to remember to include them. If you had failed to divide the diameter by 2, then that would lead to a penalty of 1 mark lost.